I'm hoping you're doing well. Welcome back to my YouTube channel. In this video, I'm going to take you through the very first video on network security basics and network access control. So the very first lab that we are doing on this, lab 4.1, is on ACL configuration. So about this lab, access control list is a collection of one or more rules. A rule refers to a judgment statement that describes a packet matching a condition, which may be matching the source address, destination address, port number, etc., etc. So an ACL is a rule-based packet filter. Packets matching an ACL are processed based on the policy defined in the ACL. So upon completion of this task, you'll be able to learn how to configure ACLs, how to apply an ACL on an interface, and also the basic methods of traffic filtering. So this is the topology. This is the topology. So R1 is excuse me. R1 is acting as a Telnet client. R3 here is acting as a Telnet server. Then R2 is our router. So as shown in the networking diagram, R3 refers to the server, R1 as the client, and they are reachable to each other. So the IP addresses of the physical interfaces are those ones there, and the IP address of the physical interfaces on R2 and R3 are those ones there. So in addition, we have two logical interfaces, loopback 0 and loopback 1 on R1 to simulate two client users. So the IP addresses of the two interfaces are that one and that one respectively. So I'm not reading them because I've already created them on the topology. So one user, which is loopback 1 of R1, needs to remotely manage R3. So this user is going to be the Telnet client, R3 is the Telnet server. You can configure Telnet on the server, configure password protection, and configure an ACL to ensure that only that user meets the security policy to log into R3 via Telnet. So that is the task that we are supposed to do. That is the task that we are supposed to carry out. So configuration roadmap, we configure IP addresses, then OSPF to ensure network connectivity, then ACL to match the desired traffic, then we can apply traffic filtering on the interface. Okay, so let's go on and do this. So step number 1, we configure the IP addresses. After the IP addresses, step number 2, we configure the OSPF and ensure connectivity. Then we can test the network connectivity using the ping command. Okay, so let's do step number 1 and step number 2. So as we can see, I've marked the network addresses and the interface IP addresses. Different from the lab topology, I've interconnected these routers on different interfaces. So just use 1 and 1, then 2 and 2 here. So I hope that will not be confusing. I did that because this router that I've used is AR2220 and it has 3 interfaces, 0, 1 and 2. So it does not have the other ones. So I chose just to use these ones for simplicity purposes. Also, earlier I had used this router with the name router, this one here. Then I realized that it does not support the traffic filter command. So that's why I changed to using this one here, AR2220. So please make sure you're using that one too. Okay. So let's go on and configure the interfaces. So on R1, we want to configure int G0/0/1 with an IP address of 10.1.2.124. Then we configure loopback 0. So loop 0 IP address 10.1.1.1, as you can see on the background there. Then we configure loop 1 IP address 10.1.4.124 like that. Then you can go ahead and configure the same on R2. So on R2, let's look at the background. We're supposed to configure G001 and G002. So we go ahead in G001, IP address 10.1.2.2.2.24, then 2, IP address 10.1.3.2.24, like that. Okay, quit. Then we can go ahead on R3 and configure the interface G0/0/2 with an IP address of 10.1.3.124. So, of course, you can always verify that you've configured the correct interfaces by using the command display IP int brief. Display IP interface brief. So you can see on R1, for example, we've configured that indeed. And we have configured loopback 0 with 1.1.1 and this one with 1.4.1 loopback 1. Okay. So as it is right now, R1 and R3 cannot communicate because of the obvious reason they don't have the routes to each other. So we can't be able to ping 10.1.3 let me clear this so that I can see the background. 3.1, which is the IP address of R3. So we can't be able to ping it. Okay, Control C to get out of that. In case you want, instead of doing Control C, you can also use the -C option to specify the number of requests that you want to send. So, for example, I just want one, then 10.1.3.1. So you just send one request, and the ping will be done. So the -C command comes in handy when you don't want to waste a lot of time. Okay, so we can now go ahead and configure OSPF on area 0. So all of this on OSPF area 0. So OSPF 1. For me, I like configuring the router ID, so I'll just configure manually there to 1.1.1, then area 0. Then in area 0, we can use the network command to advertise the IP addresses. So we can advertise the exact IP address, and we use that mask there. So 10.1.4.1, 0.0.0.0, then network 10.1.2.1, 0.0.0.0. Good. So once we are done with that, we can go ahead and configure the same on R2. So OSPF1 router ID 2.2.2 area 0. Okay. Then we can go ahead and advertise the network 10.1.2.2 0.0.0.0 and network 10.1.3.2 0.0.0.0. And we go ahead and configure R3 now. So quit here. So OSPF1 router ID 3.3.3 area 0, then network 10.1.3.1 0.0.0.0, like that. So once we've done that, we can even use display OSPF peer. So we can see that we have already formed peer with a relationship with 2.2. Okay, so at this point, if we ping R1 from here we should be able to ping it 10.1.1.1, the loopback interface over 1. We can also ping -C just 2 10.1.4.1. So you see we can also be able to ping 10.1.4.1. Okay, so the next thing then will be to configure now the Telnet server. So to configure R3 as the Telnet server. To do that, we are going to enable the Telnet function on R3 using the command telnet server enable, this one here. Then after that, we set the user level of the Telnet user to 3, and we set a login password of Huawei123. So to create a user, you use, or in order to be able to enable people to log in using Telnet, you have to create a VTY user interface using the command user interface VTY. Then you create a number of them, like this one. This command 04 will create 5 user interfaces, 0, 1, 2, 3, and 4. So meaning that 5 people can be able to telnet into this device at the same time, but not more than that. So Telnet is a technology that is used to remotely access equipment on the network or resources on the network, so that you can be able, for example, to configure them. So that's what we are doing here. Okay, so let's do that on R3. We enable Telnet and we create the user interfaces. Then after we create the user interface, we can create a user and we set a password for that particular user. Okay, so we go to R3 here. So Telnet server enable, like that. So Telnet server has been enabled. Wonderful. So we go ahead and now create the VTY interface. So let me just confirm this command here, user interface VTY. So user interface VTY 0 to 4, like that. So when we're in that view, we can go ahead and set the user privilege. So user privilege level, we know what level 3 means, like that. And then we set an authentication password for this person. So password cipher. The command cipher will scramble the saved password. Then for some routers, you'll press enter without typing any further. But for this particular one, you just have to, then it will ask you for the password and to confirm the password, like what you can see on the background here. But for this one, you'll just have to type everything on the same line. So Huawei at 123 as the password, like that. So if I press enter, then I do display this. You can see that this command, the password Huawei123 has been scrambled. So that is what the cipher command does. Otherwise, you can also configure it on plain text. So set authentication password ? Oh, this one only supports cipher. It does not support plain text. So here you can't use any other. Okay. So ? So you can see it only has one option. So you can't configure plain text passwords. Okay. So we can quit and now go to step number 4. Step number 4 is where we configure the ACL. We have two ways in which you can configure the ACL. Number 1 is we configure the ACL on router 3. We configure the ACL on R3. method number 2 is we configure the ACL on R2, on the physical interface of R2, to allow R1 to log in to R3 through the Telnet. So because both methods are almost similar, we're just going to follow the first method, which is configuring an ACL on R3. Okay, so we're going to begin by creating an advanced ACL because we want to specify that this is the service that we want to allow the IP address of loopback 1 over 1 to be able to access. So we know that for Telnet it uses TCP port number 23. So that's why we have to use an advanced ACL. So we create the ACL by using the command ACL, then the number of the ACL, it has to be between that, and then allow me to copy this rule because it's quite long. Then after that we can deny any other TCP source, then we quit. So that is all that we are supposed to do in order to create the ACL. So on R3 again, ACL 3000, then I can paste that command here. So rule 5 permit. So you want to permit you TCP source, then you specify the IP address and the wildcard mask. So we want every bit of this to match. So it's only that IP address that will be allowed from loopback 1. So that is the IP address of loopback 1. Then if you're going where? Destination. If you're going to our Telnet server 10.1.3.1. Again, we are using a wildcard mask of all zeros so that all these bits can match. So only that IP address, destination IP address, can be allowed. Then we are also specifying the destination port number. So destination port EQ 23. 23 is the TCP number for Telnet. Okay, so enter. After we've done that, we can create another rule, rule 10, deny TCP source any. So any other packet that is coming in with any other TCP source IP address, we are going to block it. Okay, so enter. Now, as it is, okay, so the next thing we need to do now is to apply traffic filtering on the VTY interface of R3. So we apply a traffic filtering on the VTY interface. So to do that, we need to go into the VTY interface. Then we use the command ACL 3000 inbound. Okay, so let's do that. So quit, then user interface VTY 04, then ACL 3000. We want to apply it in the inbound direction. Enter. So after we've done that, the next thing is we can display ACL 3000 just to have a look at it. ACL 3000. Oh, sorry. Quit. Display ACL 3000. So we can see that this is an advanced ACL. It has two rules. The ACL step is 5. So from 5, you're going to go to 10. This is the first rule. And this is the second rule in that particular ACL. Okay, so let's see what's next. Okay, let me skip that. Okay, so let's now verify that we can be able to we cannot be able to access R3 from loopback 0, but we can be able to access R3 from loopback 1. So that's what we want to do. So Telnet command enables the user to use the Telnet protocol to log into another device. So let's try that from R1 now. So here we can use Telnet. Then we can specify the source by using the -A option. So configure Telnet source IP address. So we want to first of all simulate that we are coming from loopback 0, so 10.1.1. Then destination, we want to go to R3. So R3 is on 10.1.3.1. Okay. So if I press enter, okay, so even as that loads, we can come to R3, then display ACL 3000. So when I do that, you can see that rule 10 has had 2 matches. So when we were sending the telnet here, it tried 2 times. If I do that again, now we have 3, like that. So if you want to get out of this, because it's not going to succeed anyway, you can do Control C. Control C. So you see, tells you it can't connect to the remote host. Okay, so now let's try and telnet from loopback 1, which is 4.1 there. So enter. So you can see that for loopback 1, it's already asking us for the password. So if I type the password, Huawei at 123, I think that's wrong. Good. So you can see that if I type the password and I press enter, then I'm in R3, and now I can be able to configure R3 display ACL 3000. So you can see, because I have telneted from R1, then this rule number 5 has had 1 match. The previous one that we tried had 3 matches. It tried 3 times and it was denied, and it matched this particular rule. So you can see right now we can configure R3 from R1, just as if we've logged in to R3 directly. So that is what Telnet enables you to do. Like if we do display IP int brief, we should be able to see that in R3 we've only configured gigabit Ethernet 0/0/2, whose IP address is that. So if you want to exit from Telnet, you can simply quit. So if you quit, you go back to your original device. You go back to R1. So ladies and gentlemen, thank you very much for your time. I hope you've learned how to configure ACLs. In case you have any questions, feel free to ask them on the comment section. Asanteni sana.